This is 7-2, factoring by GCF. This is actually like distributive property, except we're kind of undoing what happened. So in distributive property, you have a number that's outside the parentheses that you multiply to both terms, and you end up with 3a plus 3b. With factoring, you do the opposite. You have this expression that has a GCF, something in common for both terms. In this case, it's the 3. You take the 3, you put that on the outside, and what is left when you divide that out is what goes on the inside. So if you divide this by 3 and divide that by 3, well, 3 divided by 3 is 1a, so I had 1a left, and 3 divided by 3 here is 1b, so that's what I had left for each of those. So it's 3 parentheses a plus b. So 3 being the GCF, and the a and b being what's left when you divide. So let's see what this looks like. So for 12mp and 80m squared, you might not know the GCF right away. So the way that you can find the GCF if you don't know it off the top of your head is you do a factor tree of 12mp. When I do a factor tree, I end up with 2 times 2 times 3 times m times p. Then I take care of the 80m squared, and I do a factor tree of that. 8 and 10. Well, 8 is 2 times 2 times 2, and 10 is 2 times 5, and m squared is m times m. And I was looking to see what's in common for both of these, the GCF. So I have a 2, another 2, and an m. So 2, the GCF for this is 2 times m, which is 4m. So that's my GCF. After you find the GCF, you write that on the outside, 4m, and you put the remaining factors on the inside. So from the 12mp, if I look back at my work, I had a 3 left over and a p. So that would go first, 3p plus, and from the 80m squared, I had a 2 times 2 times 5 times m. Well, 2 times 2 is 4, times 5 is 20, times m. So I had 20m left over. And this makes sense because I took each term and I divided it by 4m. So let's take a look at that. Well, 12 divided by 4 is 3, and the m's canceled, so I had 3p left, which is what I have in my first term in parentheses. And for 80 divided by 4, well, that's 20, and m squared divided by m, we subtract these exponents, so it leaves me 1m. So you can start getting good at these and doing them in your head. Okay, and we can check our work with distributive property. If you distribute that 4m to both terms, then I would end up with 4m times 3p plus 20m. Distribute that 4m to both terms, and I get 12mp plus 80m squared. Okay, here's another example. So the first thing I would do is find the GCF. Well, I can see that all of these can be divided by 2x squared. So I might just know right away that it's 2x squared, but if you don't know that, you write out each one. So 8x to the 4th, well, 8 is 2 times 2 times 2, and x to the 4th is x times x times x times x. For 4x to the 3rd, well, 4 is 2 times 2, and x to the 3rd is x times x times x. And then for negative 2x squared, anytime you have a negative, it's a negative 1 times the other. So negative 1 times 2, and then x squared is x times x. So what we have in common here is a 2 for all of them, and an x squared, so 1x and another x in common. So that's where I got this 2x squared from. That's my GCF. From there, step 2, write the terms using the GCF and its remaining factors. So the GCF was 2x squared. What was left, when I divide each of these by 2x squared, I'm trying to see what I would have left. So you might be able to do that in your head. If you can't, you could look at what you wrote out, and you would see that we would have 4x squared left for the first one, plus 2x for the second one, minus 1 for the last one. Step 3, check with distributive property. Okay, here's example C. Negative 14x minus 12x squared. We can find the GCF of each of these. So for negative 14x, it's a negative. So negative 1 times 14 is 2 times 7, and then times x. For negative 12x squared, it's a negative. So we have negative 1 times 12, which is 2 times 2 times 3, and x squared is x times x. So in common, we have a -1, a 2, and an x. Well, -1 times 2 times x is -2x. So that's my GCF, -2x. And I'm going to write what I have left. So in the first one I had a 7, and in the second one I had a 6x. And I can check my work with distributive property. For example, D, I'm finding the GCF, but I noticed when I listed out all of my terms that there was nothing in common. So there is no GCF, so therefore this one cannot be factored. Okay, for these, this is a little bit weird. This is just a baby step of what you're about to learn. So what's happening here, I just want you to notice that two of these binomials are exactly the same, and then the GCFs are outside. So what you're going to do is you're going to write the GCFs together in one group and those matching binomials in another group. I like to call them the twins. So it's the same thing for example B. The GCF was 12b and also a 1, so plus 1. And in the inside we have, in the second group we have our twins. For example C, it cannot be factored because we don't have matching groups. These did not match. So this one cannot be factored. Okay, let's look at example 4. Factor each expression by grouping. This is where things get a little bit complicated. So what grouping means is parentheses. So I'm going to make two groups. Then from there I'm going to take the GCF of each group. So I know the GCF of the first group is 2h to the third. And that's what I'm going to divide both terms by. The GCF goes outside, and what's left over goes inside. So I'm dividing this by 2h to the third. Well, 6 divided by 2 is 3, and h to the fourth divided by h to the third, you subtract the power, so it's h. Minus, now 4 divided by 2 is 2, and h to the third divided by h to the third, there'd be no variable left. Okay, so if you don't realize that, what you have to do on the side is 6h to the fourth. 6 is 2 times 3. H to the fourth is h times h times h times h. And then 2, just kidding, -4 h to the third, well that is -1 times 2 times 2 times h times h times h. And so you can see where I got my GCF from, which was 2h, h, h. So 2h to the third. And then you can even see what was left over. So I had a 3h left in the first group and a -2 because -1 times 2 in the second group. Okay, so doing this in your head is going to make things easier over time. So in the next group, the GCF for this one is going to be 4. I know I can divide both of these by 4. So the GCF's 4. So I put plus 4, positive 4 that I'm dividing by, parenthesis, and what's left over. So 12 divided by 4 is 3h, -8 divided by 4 is -2. Notice that I have twins. So then I write one group that had, this is like from the last problem that we did, one group of the GCFs and another group of what was left over for both of them. And if you FOIL this, you'll go back to the answer over time. Not quite yet, but over time you will. Okay, here's another factor by grouping example. So grouping two groups at a time. Notice, actually I'll color coordinate this for you. So notice that I wrote on the side the factor trees for each of them, and you can see that the GCF would be 5y for the first, 5y to the third for the first one. So I'm going to take out a 5y to the third, meaning I'm dividing each of these by 5y to the third. And let's see what I have left over. Well, you can just look over here. I had a y in the first one, and then -3 for the second term. Now for the purple, the GCF of what I have here is a y. So I'm going to take out a y. So plus y. And what's left is y minus 3. So again, I'm seeing that I have, oops, didn't mean to scribble that out. I'm seeing that I have my twins right there. My GCFs are right here. So the GCF go in one group, 5y to the third plus y. And then the next would have been the twins, y minus 3. That's my answer. Factor the expression by grouping and check your answer. So here's our next one. Do this. I'm going to do this one in my head. So I know that the GCF for these are 2x squared. So that's going to go on the outside. Now I'm dividing each one by 2x squared. Well, right here, 2 divided by 2 is 1. And x to the third divided by x squared would be x, because you're subtracting the powers. And then for the second term, negative 12 divided by 2, well, that's negative 6. And x squared divided by x squared, there's no variable remaining. Plus, what can we take out of both of these? Well, I can divide out a 3. So if I divide out 3, what I'm left with is 6 minus x. These do not match. This first one is a positive x and this is a negative x. So the way that I can fix that, if I want this to be positive, then I change the signs of these. We did that when we were with subtraction. We just did it the opposite way. So I just multiplied everything by negative 1 basically for the second half, and now they match. So I have 2x squared minus 3, and now I have a positive x and a negative 6.